Okay, good morning, everyone. Thank you very much for joining us for our webinar today. Today we're going to be talking about remote sensing methods and introducing the Sensaprobe and other advanced accessories. So we'll be discussing some of the advancements Spectral Evolution has made for accessories for remote sensing applications, as well as contact measurements and leaf measurements. My name is Mackenzie Woodman, and I'm the Geology and Remote Sensing Application Specialist at Spectral Evolution. So to start off our presentation, I'm going to introduce Spectral Evolution as a company. Spectral Evolution is the leading manufacturer of high-quality UV-Vis NIR spectrometers and spectroradiometers. They're used for environmental remote sensing, as well as mining and laboratory applications, and we've been around for a little over 20 years, since 2004. We're located in Haverhill, Massachusetts, and we are built and manufactured in the United States. Some of our primary applications are in hyperspectral applications, so anything hyperspectral, remote sensing and vegetation analysis, mining and geology, as well as photonics and calibration transfer. So we have a diverse set of applications, and so we need a diverse set of accessories to make sure that data is collected in the best way possible. So to start, I'm going to talk about what a spectrometer is. So spectroscopy is the study of the electromagnetic spectrum as emitted or reflected by various materials. Reflectance spectroscopy focuses on the radiation reflected by different materials. And it's important to define the resolution needed to identify different features. So spectral resolution is very important for these kinds of applications. So our instruments target 350 to 2500 nanometers. They're considered full range instruments. They're also primarily field instruments, as well as lab instruments. So they can go in the field or they can stay in the lab and you get high quality data. So a spectrometer, to speak generally, is going to measure light. It measures the electromagnetic spectrum. And so you can either measure the quantity of light using a spectroradiometer, working in energy units, or you can work in ratio, which would be reflectance percent, which is what a spectrometer does. So looking at this figure in the bottom left, you can see that materials have a chemical composition, and these different chemical bonds will create different absorption features in the reflectance. And those absorption features, depending on your spectral resolution, can identify that material, similar to a fingerprint identifies a person. Now, when operating in reflectance for remote sensing applications, you'll be working in ratio from reference to target. And so you'll be using the solar radiation and the standoff measurement outdoors. If you're using solar radiation outdoors, then this is the typical shape of solar radiation on the left here. And so that would be your reference. That's your total amount of light that's coming down and reflecting off of that material. So that's the downwelling light, and then the light will reflect off of, on the right here, we have paved roads, bare soil, grass, water, forest, and that's going to absorb a certain amount of light and reflect a certain amount of light off of it. And the instrument will measure that light in ratio format, reflectance percent, and it will give you a reflectance percent curve in hyperspectral data. And using that, you can identify a lot of different things about the material. What is the material made of? If you're looking at soils, what nutrients are in it, what minerals are in it, in mining applications and things like that. What kind of vegetation is it? Is it healthy vegetation? All of that. And so when you're collecting measurements, it's very important to define your field of view, understand what's reflecting into your fiber optic cable that's bringing that light into your field instrument. So when considering field spectroscopy and remote sensing applications or geology applications, when you're going to be out in the field, you're in an uncontrolled environment. Your environmental conditions might change, which means your reference material or your reference light may change. So if you have a cloud go by, that would be a constantly changing environment that can change your standard, which means you would have to re-reference. So having conditions means that you need everything else to be operating at a high consistency. So you need reliability, stability, and repeatability in your instrument as much as possible so you can mitigate any generalizations that you may have to make while in the field. During a field campaign, you're going to be thinking about accessibility, portability, how far do you have to hike into the area to start taking these measurements, what is your schedule like? So you need an instrument that, what is your power requirements? So you need an instrument that's going to be able to perform for long periods of time in the field. And so these instruments are designed for that. You can swap out batteries, you can operate for long periods of time in nearly any field conditions. And then there's also the data quality, which is the most important piece, which is when you take a target measurement using our instruments, there's an auto optimization step. So all of the data quality steps that with the spectrometer are automated so that all you're selecting is one button, and then the machine will automatically do an optimization step, a dark correction, and determine the integration times for your detectors so that you don't saturate any detectors. So it ensures that you have lab quality data in the field in a timely manner. So when you're comparing to remote sensing satellites, so this would be the ground validation kind of application, you're going to be in the field with a high resolution instrument to compare to multispectral typically or coarser resolution. So the limitation in these drone applications is typically either the spectral bandwidth or the visit time or the spatial variation. So it's limited temporally, spatially, or spectrally. And so by using one of our instruments in the field, you can mitigate that because we can have, using one of our spectrometers in the field, you can have any size field of view and scan sub-pixel level in a remote sensing application. And you have the highest quality spectral resolution as well. And then the visitation time is whenever you need to be out there. So on the right here, we have a graphic that shows spatial resolution and how those change. So you can see the cones get bigger as they're further away. And the graphic on the left shows spectral resolution. And so using a field instrument allows you to address any of the limitations in the drones or satellites that you may be using. So we have a few different options for our spectrometers. We have an 1100F as well as this that will be 320 to 1100 nanometers. And then after that, we have all full range instruments, which are 350 to 2500 nanometers. And we currently have the highest resolution spectrometers on the market for field use. So you can see our NatraSpec and NatraSpec Plus, which are differentiated by their size and battery system, have a 2.5 or 2.7 in the UV-Vis, 5.5 in SWIR 1, and 5.8 in SWIR 2. And then our NatraSpec Ultra, which has the highest resolution on the market for field instruments, is 1.5 in the UV-Vis, 3 and 3.8 in SWIR 1 and SWIR 2. So these instruments are largely separated by their spectral resolution, and they're also highly sensitive due to their optical design. So like I was saying, these instruments are limited by the field conditions, and so it's important that you're using instrumentation that has adapted for those kinds of conditions and that they're reliable. So what we've done with our newer instruments is we have a portable battery that's integrated into the system. So with our NatraSpec Plus, It's integrated into the system, but on all of our units, we have portable batteries, so you don't need to plug in the instrument, and you can walk around in the field for 3 to 4 hours. With more batteries, you can go over 8 hours or as long as you need. We have wireless connectivity with Bluetooth, and we have one button operation for most of our instruments and button operation, so that you don't need to constantly be going back to a computer if you don't need it. But you have that option to look at your spectra as you go to make sure that they're high quality. So the biggest introduction that we've made this year is our Sensaprobe. The Sensaprobe is compatible with all of our instruments, and what this is going to do is that it's going to give you an operating computer on a pistol-like grip accessory, and it's going to integrate a lot more metadata into your sampling protocol. So this is designed to streamline and optimize field measurements, adding new fields and new metadata. So it's integrated an inclinometer, a distance finder, a GPS, a live field of view, and it has a field of view calculator. So it's not just giving you an image of what you're scanning, it's actually going to define your field of view based on the distance to the target. And having an inclinometer on there is also essential for different applications with in remote sensing. So this is the Sensaprobe from a couple different angles. And as you can see, it has 2 cords. It has the fiber optic cable that integrates on the end. You can put any lens on there to change the bare fiber from a 25-degree cone to a 1 through 10-degree cone, depending on how far you are, and the Sensaprobe will calculate the field of view based on the optic that you're using. Everything is magnetic, so the field tablet will be integrated on the back as on a magnet, and so you can quickly take it off if you don't want to use the Sensaprobe for some contact measurements. It also has an easy to use one button operation where if you hold it down, it will take a reference, and target is a quick button click. It also has a wrist little circlet thing that will wristband that will keep it from dropping, or if you want to hook it onto your belt, you can do that. And it has a stylus so that you can use the tablet easily. The screen's also non-reflective, so you can use it in solar illumination and still be able to read your computer screen. So field of view, like I said, is super important to define, and so there's some trigonometry that has to be done in order to define your field of view. And what the Sensaprobe is going to do is it's going to do all of this trigonometry for you, and it will define it. And so here I have a little demonstration of how the Sensaprobe works and what the software looks like. So you can see here that black circle is going to be my field of view, and I'm taking a reference measurement over a white plate. All of the metadata will be recorded in those boxes on the top right, our GPS coordinates, our solar angle, range, system temperature, and the detector temperatures as well as the inclinometer, bubble level, things like that. You'll also see the picture of the field of view will pop up in the top there in the little box, and it'll have that circle defined. Now, in that demonstration, I was using it on a shoulder strap. That's not the only way that you can use these instruments. They're often carried in a backpack. So you would have it on your back and have the Sensaprobe come over your shoulder, or the fiber optic cable come over your shoulder, and then you can use any accessory on the and operate the instrument that way. So here you can see that field of view is working with a laser distance finder. This is all made to streamline your sampling. So you have a setup tab, a live spectrum tab, alternative live spectrum, which will prioritize just the graph of the spectra. as well as a peripherals tab, trigger tab, and camera tab, where you can customize exactly how you want to be using this instrument and how you want to operate for your sampling protocol. But having the spectra in front of you in real time while you're sampling in the field lets you know if you have a bad scan or if something went wrong, or you moved the Sensaprobe and didn't hit the target that you wanted to hit, then you have all that metadata stored so that you're not integrating bad data into any models or things like that. So to show you some of the other settings, you can operate this instrument to collect energy measurements. You can normalize your scans to normalize it to 1. You can look in calibrated radiance or irradiance, raw detector counts, however you want to customize. It also allows you to turn off the water band. So in solar illumination, there's 2 parts where the atmosphere absorbs 100% of your signal. And so working in ratio, that creates a lot of noise in those areas. And so you can turn those off. It'll still collect the data because that can be useful data, but it will turn those off for graphing so that it doesn't blow out your y-axis, which is very useful. So now I'm going to move on to some of the other accessories. We have inline diffusers. So this is an optic that you can use with the Sensaprobe and any of our instruments. This is typically used for irradiance measurements, but what this is going to do is it's going to collect, or it's going to give you a 180-degree cone or 180-degree field of view. So this is a great way to measure downwelling or upwelling radiance or irradiance. It's compatible with the pistol grip. You can mount it on a tripod. It's a great way to get that 180-degree field of view to classify like light bulbs or energy in a system, things like that. We also have our contact probe. And so this is primarily used for soil and geology applications, anything that you want to be in direct contact with. And so this accessory has a tungsten halogen light source inside as well as a sapphire lens. So what that's doing is the tungsten halogen light source is going to give you energy across the entire field of view, or in the entire spectral range. So 350 to 2500 nanometers. And the sapphire lens is going to be non-scratch. So that's typically harder than any of the outcrops that you're going to be putting it on. So you don't have to worry about scratching the lens and having bad data due to that. It's also easy to clean. So we have 2 different options for sizes of these contact probes. We have a mini probe, which is a 3mm spot size, and our contact probe, which has a 10mm spot size. So that's our contact probes. They're very versatile. The rubber gasket that's on them is not actually to protect it. That's to keep out light from the room. So if you've ever tried to take a reflectance measurement using LEDs, they don't have a lot of energy. They just have energy in our visible light. And so you won't get good data using that. So you want to make sure you mitigate any of the light from outside and that you're just standardizing it with that internal light source. Now, for loose materials like soils that you want to take samples from, or any kind of lab application where you have powdered samples, so pharmaceuticals, drug, geology, soils, this is a great way when you get back into the lab to pack these pucks full of loose materials, and then you can scan them with a high energy tungsten halogen light source as well. So this is going to give you good data on loose materials. So it's a very similar design where it has that sapphire lens or window that's going to be able to take quality data off of reflectance data off of these loose materials, and you can characterize them, and you have these pucks, so they're very repeatable measurements as well. Our other option is our leaf clip. And so this leaf clip, the design of this is it also has the same similar light source, where it has energy across the entire spectral range, but that light source is sent through a fiber optic cable to eliminate any of the thermal output that goes onto the sample. And it's designed to clip directly onto a leaf. And so what that does is it makes sure that you're not drying out the leaf when you're scanning it, and you're not manipulating it. So you can have repeatable measurements on these leaves without burning holes in them and things like that. So that's our leaf clip that's designed to do vegetation analysis, but it can also be used for any sensitive materials like cloths or characterizing those kinds of materials. We also have a surface probe that is a very similar design that's made to be used in flat on a table. And then we have this pine needle adapter that adapts the leaf clip to be able to scan an individual pine needle. So you can be as targeted with this leaf clip as you want. And some of the benefits of that pine needle adapter is that typically when scanning these kinds of thin materials, scientists have taken to bundling them together, which causes shadowing of adjacent needles, multiple scattering, and reabsorption. And so by scanning an individual pine needle, you're much more controlled in your kind of study, and you can be more accurate in it. And so it creates a much more reliable and repeatable measurement. And so what that does is you actually take a scan of your dark or unloaded pine needle adapter, and that will be subtracted off after you scan the pine needle in it. Some of the software innovations that we've made is that these instruments are compatible, and you can use multiple instruments at the same time. So you can start to take simultaneous measurements. So you can take upwelling and downwelling. In this case, I have a picture where we were characterizing a solar eclipse. So I had total horizontal irradiance as well as direct radiance measured from a Gershon tube. And so you can get very creative with how you use two instruments at the same time. So you could take reflectance measurements where you're taking a reference measurement simultaneously with a target measurement, which is much more accurate, especially if you have intermittent clouds or things like that. You can also start to do energy measurements where you're subtracting one from another and things like that. So it's very useful to be able to use these at the same time. And then another software innovation that we have is our easy ID identification. And so like I was saying earlier, Spectra is like a fingerprint. These absorption features are caused by the spectral or the chemical composition of these materials. And so you can exploit that by comparing it to spectral libraries. And our easy ID spectral analysis software allows you to create match regions to unmix spectrally complex spectra and match it to a mineral library or soil library or vegetation library. And you can customize these libraries and build them within Easy ID to use that. So it's a very innovative tool and a great accessory for spectral analysis. So in conclusion, remote sensing and mining is a constantly evolving field that requires robust and versatile instrumentation. Integrating new accessories and innovating on accessories like the Sensaprobe advance the field collection by streamlining data collection and creating consistent data. And it is incredibly important to use the correct accessories and instrumentation for the job that you're doing. So thank you very much for listening today, and I'm happy to answer any questions, or you can email me if you're interested in an accessory, and I'd be happy to help you pick the right one. So thank you very much.